All right, welcome to this explainer. If you are currently sitting in front of a 24 gigabyte M5 MacBook Pro, you are literally holding a staggering amount of compute power. Today, we're going to look at exactly how to transform that specific incredible hardware setup into a high-performance personal AI laboratory using Unsloth Studio. We're going to completely break down the exact methods to train large language models right there on your machine without needing an internet connection or, an outrageously expensive cloud subscription. Let's get into it.
Okay, let's dive into this. The absolute biggest question we always face when talking about local AI is this. Can a laptop, even a really good one, truly rival a dedicated cloud GPU server for fine-tuning? Well, historically, the answer was just a flat no. You'd hit massive compute and memory bottlenecks almost immediately. It was a non-starter. But your M5 Mac, it completely changes the rules. It empowers you with this new reality where your Mac actually is a personal AI lab. It's totally capable of handling complex model training that until very recently required massive racks of servers.
To get why this actually works, you kind of have to look at the hardware architecture. Notice how traditional discrete GPUs, like the ones you'd find in bulky Windows workstations or those big cloud servers, they rely on constantly moving data back and forth across a high-latency PCIe bus. It's basically a massive traffic jam. But Apple's Silicon utilizes a high-bandwidth unified memory architecture. What that means is your CPU and your GPU share direct, zero-copy access to that exact same 24 gigabyte pool of physical memory. This drastically reduces those memory transfer bottlenecks during the super heavy tensor operations you need for AI. It literally gives you server-grade efficiency on your desk.
So, here's our roadmap for today's explainer. 1. The local AI Mac revolution. 2. Shrinking AI with quantization and distillation. 3. Crafting the perfect dataset. 4. Optimal fine-tuning in Studio. And finally, 5. Debugging and known limitations. All right, moving right into Section 2, shrinking AI through quantization and distillation.
So before we literally just click train, we absolutely must understand the underlying magic that makes local training on just 24 gigabytes possible in the first place. And the first piece of that puzzle is a pretty dense academic concept called knowledge distillation. But let's just break it down using a really simple teacher and student analogy. Think of a massive, state-of-the-art cloud model as this master professor, right? And your smaller open source model is a super bright but, inexperienced freshman. We actually use the powerful teacher LLM to generate incredibly high-quality dataset annotations, complex reasoning steps, and conversational sequences. Then we just feed all those sequences to the smaller student model. This is exactly how we make smaller open-source models so incredibly smart. We're essentially transferring the generalized knowledge of a massive model into a tiny, manageable footprint.
But here's the catch, right? Even a smaller student model can completely overwhelm 24 gigs if we aren't careful. Here, we're visually contrasting a massive pre-trained base model with a quantized QLoRa model. See, standard fine-tuning requires you to keep all the model's weights in high precision, and that just eats up memory instantly. A quantized QLoRa model, however, it freezes the base weights in a highly compressed 4-bit format, and then it only updates a very, very small, low-rank adapter right on top of it. So you get all the underlying intelligence of the full model, but the whole thing takes up a mere fraction of the space. It's brilliant. And this brilliantly illustrates the real-world impact of these compression techniques. Just looking at this chart, you can clearly see how advanced quantization-aware fine-tuning methods maintain incredibly high accuracy, all while drastically improving inference speed. When you compare it to older methods, like GPT-Q down there in the bottom right, modern methods push us way up into that ideal top right corner. It means you absolutely don't have to sacrifice a model's brain power or, melt your laptop into slag just to make the model fit.
Okay, Section 3. Crafting the perfect dataset. Quality over quantity.
When you're working on a local workstation, your instruction tuning success relies entirely on the quality of your data, not the volume. Honestly, if you are sourcing data from the web, do not just grab massive unfiltered text dumps. Please. Instead, you want to look at these specific, highly filtered dataset mixtures coming straight from the research literature. For example, the Lima dataset proved that just 1,000 carefully curated human-written pairs can create a deeply aligned model. Then you've got No Robots, which gives you 10,000 expert-crafted instructions. For more general tasks, OpenHermes 2.5 is just a fantastic mix of synthetic and human data. And hey, if you want your model to interact with databases, Gretel Synthetic Text-to-SQL provides some truly excellent domain-specific reasoning. Basically, start with these to establish a really strong baseline. But what if you actually want to use your own private company documents? Well, that is exactly where Unsloth's data recipes pipeline comes in. It uses this really great visual node-based workflow. First, you just upload your raw, unstructured files like PDFs or CSVs directly into the browser UI. Next, you format your target variables using simple curly braces. Then, the system actually leverages NVIDIA Data Designer under the hood to synthetically generate and structure your training examples. Finally, it exports the whole shebang into a standard format, like ChatML, that your model can actually understand. It completely effortlessly takes messy human documents and seamlessly turns them into a structured, instruction-following dataset. It's a real game changer.
All right, Section 4. Optimal fine-tuning in Studio, the unified interface.
So with our model compressed and our dataset perfectly crafted, let's go ahead and open Unsloth Studio. Now, what's really interesting about this slide is how we get this running natively on a Mac. See, Unsloth's core technology was originally built on highly optimized Triton kernels made specifically for NVIDIA CUDA GPUs. However, to bring this to your Mac, native Apple silicon wrappers like MLX Tune actually swap out that backend for Apple's own MLX framework. And this vital shift is what allows the software to completely bypass traditional VRAM limits and tap directly into your Mac's massive unified memory pool. It completely eliminates the need to juggle separate tools for inference, training, and testing. It's all right there.
When you boot up Unsloth Studio, you're greeted with this incredibly clean dashboard, naturally divided into 4 core workspaces. The Model tab lets you seamlessly search and download weights directly from Hugging Face. The Dataset tab is where you load up those files we just prepped. Now, the Parameters tab is brilliant because it automatically configures your hyperparameters based on your specific hardware, which takes the guesswork completely out of the process for you. And finally, the Training tab gives you these beautiful live charts to monitor your progress. It takes what used to be a deeply complex, code-heavy task and turns it into a rapid, click-driven setup. So here's the absolutely crucial takeaway. When you are in that interface configuring your run, you must choose QLoRa as your fine-tuning method. Because it utilizes that 4-bit quantized base model we talked about earlier, it requires the absolute least amount of memory possible. Actually, scratch that. For a 24GB limit, QLoRa isn't just the best choice, it's really the only practical method over full fine-tuning. It's the one thing that guarantees you won't crash your system with those dreaded out-of-memory errors halfway through a run. Okay, so your training finishes, now what? You hit what developers call the export gap, basically figuring out how to actually use the thing you just spent hours building. Unsloth Studio solves this instantly with one-click exports, which is just an absolute relief. You can package your shiny new model into a GGUF format, which is highly optimized for local consumer hardware. If you're pushing to a server later, you can export to VLM for high-throughput production. Or you can push it directly to Llama for immediate, local chat testing right there on your desktop.
All right, last part, Section 5, Debugging and Known Limitations, Navigating Mac-Specific Pitfalls.
Look, setting up a local dev environment is never 100% seamless, right? Your absolute first and most important pro tip here is environment isolation. If you've ever broken your Mac's system Python, you know exactly how incredibly painful that is. You have a very strict Python requirement here. You absolutely must use version 3.11 up to, but specifically not including version 3.14. You're going to want to manage this installation using Homebrew and a virtual environment manager like UV. Trust me on this. It will totally prevent those messy macOS system package conflicts that can corrupt your entire setup.
You also definitely need to keep an eye out for a couple of known bugs in the current architecture. First up, during installation, you might see a Llama server build failure. If this happens, don't panic. Just clear the corrupt build cache and verify that your CMake tool is properly installed and actually in your system path. Second, regarding the Apple MLX framework itself, there is a known limitation where the direct save_patrain_guguf command just does not work correctly if you are exporting straight from a 4-bit quantized base model. Knowing these 2 quirks alone will save you hours of frustrating troubleshooting.
So there you have it. You've got the unified memory of the M5 Mac, the sheer brilliance of quantization and distillation, and the streamlined, no-code interface of Unsloth Studio. You are no longer totally reliant on the cloud. So I leave you with this provocative thought. What domain will you conquer first, now that you have a private, immensely powerful personal AI lab sitting right there on your desk? Take all this knowledge and go start building. Thanks so much for joining me on this explainer.